When we chose to go with Purdue Calumet and we had the meeting, before we had the meeting, our research background into Professor Chin's accomplishments was very impressive. She'd worked with a lot of industries. She'd delivered a lot of product to those industries in terms of things that they needed. It showed a good practicality working with industry. It also showed that she was willing to work with industry. She had actually gone out and helped them. And as we did more work, we found out, or more research, we found out that she could deliver practical results to the companies as they requested them. And that's what we were looking for, because there's a lot of research done by other organizations, but they have no practical consequence of what they've done. And you look at information, you get data and outputs and stuff, but you can't relate that into actual something you can use in the field. And that's what we saw, was a lot of publications, a lot of industry interaction, and continued interaction with those same industries. So there was a great long history of that also proved that she was capable. And so when we came here, we looked at the people that I started working with, not just Professor Chen. She involves her students, involves her other people, very close-knit with you, and that relationship works out very well because you have one-on-one contact with people, and that makes a lot of improvement in the products you're going to get. We came to Purdue University Calumet because we did some research concerning trying to do simulations, CFD type simulations, and we looked at several organizations, and the one that stood out was Professor Chen's work in this field. And so we decided to pursue that with her, have a discussion, and then we got introduced to the civis side of what she did, and that even enhanced more what we wanted to pursue. So that's why we came to Purdue Calumet. Seemed like a good fit for us, and they were very practical oriented, which is, you don't see that too much when you deal with universities doing this type of modeling. The biggest benefit I see to this type of organization, this type of interaction, is you're training individuals. Granted, they're more technical, but you're training people that are more in line with what the real world is out there. You're not just training engineers or some technical form of training with these individuals where they come to the school and they leave the school and they got all kinds of academic, but they have no practical experience. This interaction with the industry, I think, gives them a benefit of knowing what they're going to face out in the real world. It also gives industry a chance to interact with and find individuals that are more oriented to what they want. So it works both ways. And I think industry needs to support this type of facility, because some bigger industries may be able to afford to develop this on their own, but they're not. And so this is a way to share resources. And so I think this is a good place to do this, and I think she's done an excellent job of bringing it together. Okay. Lazar Anode Tech is a startup company that's curing anodes for the aluminum smelting industry. And we're just building a facility, but we had some good data from pilot plant studies, but we hadn't actually tried to build the facility we're doing now. And we were concerned about some of the results that we might get, so we wanted to model some of the features of that design, which is patented, and make sure that we got it right when we built this facility. So we came here to Purdue Calumet, hoping that they could model both thermally and flow-wise our furnace for us, and give us some insight as to things we may have to change. And we did have a successful model results, which actually showed us we needed to change our design. So we stopped construction and we started a change in our design, and now we're restarting construction with that design change. And we're continuing modeling with Purdue right now. The only problems that we were concerned about was the temperature and flow patterns within the furnace. And this is why we came here, just to get that. Since we don't have an operating facility yet, we can't pursue anything further than just doing a basic modeling of the structures and the design. And then we pursue later, hopefully, once we get it up and operating, trying to enhance and optimize that design through modeling. CIVUS, when we got introduced to the modeling and then the simulation, and finally, following the simulation, we actually got to see some things in 3D. We realized we had flow patterns of temperature and flow of gas that was different from what everybody had visualized in the past, which also showed us why we weren't getting the correct response in the heating of our anodes. So by doing that simulation and actually seeing what's going on, that promoted a change in our design, which we have, like I said, integrated now, and we're hopefully that given the model results we just recently looked at, we think we've solved our problems and improved the quality of the product we're going to make.